This is the continuation of our discussion on work, energy, and power. Let us begin with gravitational potential energy. So, an object can store energy as the result of its position. For example, the heavy ball of a demolition machine is storing energy when it is held at an elevated position. Now, this stored energy of position is referred to as potential energy. Potential energy is the stored energy of position possessed by an object. The most common potential energy is gravitational potential energy. Gravitational potential energy is the energy stored in an object as the result of its vertical position or height. The energy is stored as the result of the gravitational attraction of the Earth for the object. Now let us consider this illustration. So, for example, a ball falling from this position, the initial position, HO. So, at this point, the ball is falling downward at this position. At that position, this is the initial position, then this is now the final position of the ball. So this is the final position. That is why this is your displacement S, if we will be looking at the figure. So work, according to our equation from our previous discussion, work is F cosine theta S. And as I've discussed, sabi ko nga sa inyo, if the cosine theta is 0, then you can already disregard this because cosine theta is just equal to 1. But in this illustration, the work done is caused by the gravity. Okay, the work done is caused by the gravity. Therefore, the force acting on the object is just its weight times its displacement. But weight is equal to mass times gravity. That is why the work done of the gravity is equal to mg, the displacement, initial minus final. Now this is your equation for gravitation, work done by the gravity. But gravitational potential energy, like for example in a two-dimensional, so this is this illustration. First, the ball is just falling downward, one directional, vertically, and a ball being thrown two-dimensionally, thrown in this illustration. Now we just have to disregard the path taken by the ball because it will just the initial position and the final position. We just have to consider the initial and the final position, but we disregard the path taken. So kahit downward lang siya, one directional, or given a two directional, it doesn't matter. What matter is the initial position of the ball and its final position. So we disregard the path. Okay, so work done by the gravity is equal to mg, times the displacement, or mg times the quantity h sub o minus h sub F. Now let us try to solve this example. So the gymnast leaves the trampoline at an initial height of 1.20 meters and reaches a maximum height of 4.80 meters before falling back down. What was the initial speed of the gymnast? So let us try to solve this problem. Now this is the illustration. This is the trampoline with an initial height of 1.20 meters. Let us try to so let's say this is the level of the trampoline and this is the ground. Let's say this is the trampoline. So this is 1.20 meters. This is the initial position. So of course the gymnast is at that position on the face of the trampoline, and when the gymnast jumps it reaches a maximum height of 4.80 meters. Let's say this is the maximum height at this point. So the final height of the gymnast, it reaches a maximum of 4.80 meters from the ground. 4.80 meters. This is your height final. 4.80 meters. So the gymnast jumps going up, and the initial position is 1.20 meters, and the maximum height reached by the gymnast is 4.80 meters. Now let us look at the solution. We're being asked, we're required to get the initial speed of the gymnast, therefore the velocity at this point, the takeoff velocity. So we're being asked to find this velocity just before the initial speed or the initial velocity of the gymnast. Now work, from our work equation from our previous discussion, is that work is kinetic energy final minus kinetic energy initial. So work is kinetic energy final minus kinetic energy initial. But work done by gravity is equal to mg times its displacement, HO minus HF. Now if we will equate these two equations, replacing the W here by the work done by the gravity, which is equal to mg HO minus HF is equal to negative 1/2 mv O squared. So you'll notice na nawala yung mvf squared. Why is it so? Because at the maximum height, when the gymnast reached the maximum height, the velocity there is 0. So the final velocity is 0 because the gymnast will momentarily stop at the maximum height. Then it will start to go down. So that is why the final velocity at the maximum height is 0. So what remains in the equation is negative 1/2 v sub O squared. Now if we will try to derive an equation for initial velocity, we will have this equation. Let us try to have the derivation so that you will see how it arrived to the square root of negative 2g over times the quantity HO minus HF, the square root of this term. So let me first erase this. So we have an equation. We have mg is equal mg times the quantity HO minus HF is equal to negative 1/2 mb sub O squared. So by just cross multiplying, we'll have here negative 2 mg quantity HO minus HF is equal to m v sub O squared. So we need to divide this by m, divide this also by m, so the mass here will be cancelled. So what will remain in our equation is v sub O squared is equal to, simplifying this equation, is negative 2g times the quantity HO minus HF. So therefore v sub O, the initial velocity, is the square root of this term, negative 2g times the quantity HO minus HF. So this is now the equation for the initial velocity of the gymnast. So by just substituting the given, the square root of negative 2 times gravity 9.8, HO is 1.20 meters according to the given, then minus the maximum height final 4.80 meters, the answer would be 8.40 meters per second. So this is an example problem. Now again, by definition, the gravitational potential energy or potential energy is the energy that an object of mass m has by virtue of its position relative to the surface of the earth. That position is measured by the height h of the object relative to an arbitrary zero level. So by mathematically, potential energy, so gravitational potential energy or just potential energy, mathematically is equal to mass times gravity times height. So this is now our equation for potential energy. That potential energy is equal to mgh, mass times gravity times height. Our kinetic energy from our previous discussion is 1/2 mass v squared, velocity squared. So this is potential energy and kinetic energy. Now let us talk about conservative and non-conservative force. So what is a conservative force and a non-conservative force? Conservative force, the definition of conservative force: a force is conservative. Okay, that's the first condition. A force is conservative when the work it does on a moving object is independent of the path between the object's initial and final position. And the second definition is that a force is conservative when it does no work on an object moving around a closed path, starting and finishing the same point. So, finishing at the same point. So, if you'll try to remember, doon sa ating illustration kanina, the falling ball on gravitational potential energy. So, we disregard the path taken by the ball. So, it's either, it's kahit pa one direction lang siya pababa or two directional yung kanyang position, it doesn't matter. So, we can consider that gravitational potential energy is an example of a conservative force. So, version 1, a force is conservative when the work it does on object is independent of the path between the object's initial and final position. So, like what I'm telling you, the gravitational potential energy on our illustration, like the ball earlier, so it's whether it is just going straight downward or in a direction two-dimensionally, this path taken by the ball is we disregard the path taken by the ball. So we can consider that gravitational potential energy is a conservative force. Version 2 of the definition. So a force is conservative when it does no work on an object moving around a closed path, starting and finishing at the same point. So like for on this example, a roller coaster. So a roller coaster, as it goes down and travels on this path, going around and going back to its starting point, then it does no work on the object, because technically your initial point is equal to your final point. Therefore, your displacement is 0. So since the displacement is 0, the work done by the gravity on this illustration is also 0. So this is also an example of a conservative force. So a conservative force is one like the gravitational force, for which work done by or against it depends only on the starting and ending point or the final point of a motion and not on the path taken. And we can define a potential energy for any conservative force just as we did for the gravitational force. For example, ito din example, hindi lang sa gravity but even sa spring. So for example, when you wind up a toy, an egg timer or an old-fashioned watch, yung mga laruan natin na may spring, tapos yung mga music box, that's like the music box. So you do work against its spring and store energy in it. So we treat these springs as ideal, and in that we assume that there is no friction and no production of thermal energy. So this is stored energy is recoverable as work, and it is useful to think of it as potential energy contained in the spring. So indeed, the reason that the spring has this characteristic is that its force is conservative. That is, conservative force results in stored or potential energy. Gravitational potential energy is one example, as is the energy stored in a spring. So we will also see how conservative forces are related to the conservation of energy. Now, how about non-conservative force? So what is the definition of a non-conservative force? A non-conservative force is one for which work depends on the path taken. Friction is a good example of a non-conservative force. Work done against friction depends on the length of the path between the starting and ending points. So because of this dependence on path, there is no potential energy associated with non-conservative force. An important characteristic is that the work done by a non-conservative force adds or removes mechanical energy from a system. So I think that is one of the recognizable difference between conservative and non-conservative force. Sa non-conservative force, it's either nag-a-add or nagre-remove ng energy from the system. Okay? So again, it adds or removes because energy from the system is being transformed. Okay? It is not being lost actually. It is just being transformed. Like for example, sa friction. Kapag merong friction, na-transform ang ibang energy into heat. So like for example, if you rub an object, because of friction, it will generate heat. So it either adds or removes mechanical energy from a system. So friction, for example, creates thermal energy that dissipates, removing energy from the system. So furthermore, even if the thermal energy is retained or captured, it cannot be fully converted back to work. So it is lost or not recoverable in that sense as well. So that is non-conservative force. Hindi tulad doon sa conservative na nare-recover, parang tulad nung sa spring, ano. So an example of non-conservative force is the kinetic frictional force. Now work is F cosine theta times the displacement S. Now if we will consider that the kinetic frictional force Fk times cosine 180 degrees times the displacement. Why 180 degrees? Because friction always opposes the motion of the object. Like for example, if the object is going to the right, then friction is going to the left. So it is always going the opposite side. That is why it is on the 180 degree of the motion. And cosine 180 degrees is negative 1. Okay? Cosine 0 is 1. But cosine 180 degrees is negative 1. That is why W will just be equal to negative Fk, or the kinetic friction, times the displacement. So the work done by the kinetic frictional force is always negative. Thus, it is impossible for the work it does on an object that moves around a closed path to be zero. So the concept of potential energy is not defined for non-conservative force. Of course, because potential energy is conservative. So these are just example of some conservative and non-conservative forces. Conservative forces like gravitational force, elastic spring force, electric force. Non-conservative, static and kinetic frictional forces, air resistance, tension, normal force, and propulsion force of a rocket. Now, in normal situation, in reality class, both conservative and non-conservative forces act simultaneously on an object. So, sabay silang nag-a-act sa isang system or sa isang object. So, the work done by the net external force can be written as, this is now the total work, which is the total work is the work conservative plus work non-conservative. Okay? Now, we all know that work, according to our previous discussion, is the change in kinetic energy. That is why work is kinetic energy final minus kinetic energy initial. But conservative work, just like the work done by the gravity, is mg times the quantity HO minus HF. Actually, mgh is our potential energy. And mgHO is our potential energy initial minus mgHF, our potential energy final. Therefore, if this total work is the change in kinetic energy, this conservative work is just the negative change of your potential energy, negative delta PE. This conservative work. Now, so work is the change in kinetic energy. The work conservative is the negative delta of potential energy, a negative change of potential energy, plus the work done of the non-conservative force. So if we will just rearrange the equation, we can find the work of the non-conservative force, which is the work energy theorem. So if we will just transfer the change in potential energy, the non-conservative, the work done by the non-conservative force is just equal the summation of the change in kinetic energy plus change in potential energy. So it is just the sum of the changes of the kinetic energy and potential energy on the system. So WNC is equal to delta KE plus delta PE. So non-conservative, the work done by the non-conservative force is delta KE plus delta PE. So this is kinetic energy final minus kinetic energy initial plus the quantity potential energy final minus potential energy initial. So if we will add both the final variables and the initial variables, kinetic energy final plus potential energy final, then kinetic energy plus kinetic energy initial plus potential energy initial. Now the sum of all the kinetic and potential energy is actually the total mechanical energy of the system. That is why kinetic energy final plus potential energy final is energy final. Therefore, this is the total energy. Total mechanical energy final minus total mechanical energy initial of the object. Okay, so if the net work on an object by non-conservative forces is 0, then its energy does not change. So if the work NC non-conservative is 0, of course energy final is equal to your energy initial. Okay, so that your work done by the non-conservative force is 0. Okay, so the principle of conservation of mechanical energy. So the total mechanical energy E is equal to the sum of the kinetic energy and the potential energy of an object. It remains constant as object moves, provided that the net work done by external non-conservative forces is 0. So this is the principle of conservation of mechanical energy. So if we'll try to look at this figure, for example, this slide going downward. So at the maximum height, its kinetic energy is 0 joules. But it has potential energy maximum, which is, this illustration is 600,000 joules. So if we'll try to add the total mechanical energy, kinetic energy plus potential energy, it is 600,000 joules. Now along the path going downward, the kinetic energy and potential energy, or the total mechanical energy, should always be equal to 600,000 joules. That is the principle of conservation of mechanical energy. Now, for example, as this slide goes down, as it travels downward, its potential energy losses. Nababawasan yung potential energy. Bakit? Nababawasan yung height. Bumababa ka. So, yung nalolos na potential energy actually, nako-convert siya into kinetic energy. Bakit? Kasi nagkaroon na ng velocity yung slide. Dito sa starting point, 0 siya. So, habang nagkakaroon siya ng velocity going downward, yung kinetic energy mo tumataas. Yung potential energy mo ay bumababa. Kasi nga, yung height mo ay nababawasan. But still, the total mechanical energy dapat laging equal sa 600,000 joules. So again, as it goes down, at this point, for example, near the end point, so pataas ng pataas yung kinetic energy, pababa ng pababa yung potential energy. Until it reaches this point, at the lowest point, wherein all of your potential energy was converted to kinetic energy. So at this point, at the lowest point, 0 joules na ang potential energy mo because your height is already 0. Therefore, potential energy is 0. kinetic energy naman is at maximum. Bakit? Because at this point, you have the final velocity is maximum. Dito pinakamabilis na ngayon yung object. So yung velocity mo dito maximum na rin, kaya andito na yung maximum kinetic energy. So this is an illustration for the conservation of mechanical energy of a system or of an object. So an example problem, a daredevil motorcyclist. So a motorcyclist is trying to leap across the canyon by driving horizontally off a cliff with the velocity of initial velocity of 38.0 meters per second. Ignoring air resistance, find the speed with which the cycle strikes the ground on the floor on the other side. So the initial height, the height of the cliff is 70 meters. Then the initial velocity of the motorcyclist is 38.0 meters per second. Then the height final of this canyon, dapat malagpasan niya ito. V final is here, then the height final is 35 meters. So from 70 meters, dapat malagpasan niya itong 35 meter na canyon. Itong parang dito, plateau at this point. So we are asked to find the speed with which the cycle strikes the ground on the other side. So we are asked to find this final velocity on the other side of the canyon. Now, so at this point, we assume that the mechanical energy is conserved. Okay? Therefore, from this point at the highest position to the lowest position at this point, the total mechanical energy should be conserved. So the energy final at this point is must be equal to the energy on the initial position. Now energy final, we all know that energy final, so energy final is equal to energy initial. But energy final is the sum of your kinetic energy final plus potential energy final is equal to kinetic energy initial plus potential energy initial. That is why this is kinetic energy plus potential energy. This is 1/2 mv final squared plus mgh final is equal to 1/2 mv initial squared plus mgh initial. Okay, but our initial our v final, we're asked to find v final. So we have mass of the motorcyclist. Then we have no, we don't have mass actually, but you don't have to worry because this will just be cancelled, because we'll have m times 1/2 v final squared plus g hf is equal to m times 1/2 v sub o squared plus g h sub o. So this mass will be cancelled, leaving us with this equation. 1/2 vf squared plus g hf is equal to 1/2 v sub o squared plus g h o. So it's just the same equation with this on our left side. So GHF plus 1/2 v squared f is equal to GHO plus 1/2 v sub o squared. So by just deriving an equation for v final, so v final will be equal to the square root of 2g times the quantity h sub o minus hf plus v sub o squared. And substituting all the given to this equation, we will get the final velocity or the velocity of the motorcyclist at this point as it passes the 35-meter canyon. Then the final velocity at this point is equal to 46.2 meters per second. So this is an example of solving a problem with the principle of conservation of mechanical energy. Now, the work energy theorem. Now, according to our discussion earlier, we discussed about the non-conservative force, where the non-conservative force is just equal to your energy final minus energy initial, by just rearranging the kinetic energies and the potential energies of the system. So that's what we discussed earlier. Now, energy final, of course, this is the potential energy final plus the kinetic energy final minus initial, of course, the potential energy initial plus the kinetic energy initial. So let us consider this problem. For example, the rocket. So assuming that the non-conservative force generated by the burning propellant does 425 joules of work, what is the final speed of the rocket? Ignore air resistance. So this is an example of non-conservative. Kanina conservative yung diniscuss natin. That is why the mechanical energy is being conserved. Dito sa non-conservative force, we have this work energy theorem. The mechanical energy is not conserved. So we have because the system, it's either add or remove energy. So just like this one, energy is being removed from the system in the form of heat of the rocket. Now, the initial velocity is 0 meters per second. Then at this point, we are being asked to find the final speed at a maximum height. Okay, here's the initial height and here's the final height. So it's not given, no? But what is given is that the burning propellant does 425 joules of work. So what is the final speed? Now, from the initial point to the maximum point, ito ay it reaches a maximum height of 29 meters. Now let's try to solve for this problem. So WNC is equal to mghf minus mgho. Again, by just rearranging our terms. So WNC is mghf minus mgho. This is the potential energies, plus 1/2 mv squared minus 1/2 mv sub o squared. This is also the kinetic energies. So WNC is equal to mg, the quantity hf minus ho, plus 1/2 mvf squared. So this term 1/2 mv sub o squared becomes 0 because the initial velocity is 0. So we will just be left by this equation, and what we are asked is the v final squared. So by just substituting these givens to our equation, we will have v final be equal to 61 meters per second. The non-conservative work, the work done by the non-conservative force is 420 joules. The mass is 0.20 kilogram. The gravity is 9.80 meters per second squared. 29 meters. This is now the change, the delta, the change of height. Ito na yan. Because HF minus HO is 29 meters plus 1/2 the mass, 0.20 kilogram, then VF squared. So by just substituting all the given of this problem, we will get the final velocity of 61 meters per second. So the first problem is a problem for conservative forces, and this problem this problem is on non-conservative. So yung problem natin dito is ito conservative, then ito ay non-conservative because the energy is being removed from the system. It is being transformed. Okay, so let us go to power. Definition of average power. Average power is the rate at which work is done, and it is obtained by dividing the work by the time required to perform the work. So power is equal to work over time. So work is in joules, times is in seconds, and joule per second is watts. Yes, this is watts. And we commonly heard watts in electricity. Like for example, sa mga bulbs, sa mga lamps. So, may maririnig ninyo ilang watts yan. Sa mga appliances. So, that is power. Work over time. Joules per second. 1 joule per second is equal to 1 watt. So, power is change in energy. It is the rate of change in energy over time. This is another unit for watts or power. 1 horsepower is equal to approximately 745.7 watts, or this is being approximated to 746 watts. So commonly maririnig nyo din siya sa, like for example sa aircon, sabihin nyo how many horsepower. So that's why you can hear like it's 0.5 HP or 1 HP, 2 HP. It means horsepower. So we can just convert it to watts by this conversion factor. That 1 horsepower is approximately equal to 746 watts, or exactly equal to 745.7 watts. Now, power also can be equal to force times velocity. How did this happen? So, if power is work over time, okay, but we know that work is force times the displacement all over time. Power is F times S over T. So if you remember, the displacement over time is your velocity. And our kinematic equation, this is X, not S. So X over T, that is your velocity. That is why power is also equal to force times the velocity. Okay, so we have it's either power, work over time, or we can have this equation, power, force times velocity. So like this, for example, we also consume, as we work, we also consume power in our body. So like for example, if we run and with a velocity of 15 kilometers per hour, then we are burning energy in our body. We are generating actually energy equal to 1340 watts. Skiing is 1050 watts, biking 530 watts, walking with a velocity of 5 kilometers per hour 280 watts, sleeping is 77 watts. So this is how we generate power in our body, metabolic rates, human metabolic rates. So the principle of conservation of energy, again, energy can neither be created nor destroyed, but can only be converted or be transformed from one form to another. We cannot create nor we cannot destroy energy. We can only transform it. So like for example, earlier I mentioned about friction. And when you have object, energy is being transformed. Actually, it's not being lost. Yes, it is being lost from the system, but it is just being converted to heat. Okay, so we cannot create nor destroy energy. We can only transform it. So constant force, of course, work is F cosine theta S. If it is variable, okay, what does it mean variable? That the work is changing. The force, for example, is changing. So, of course, halimbawa, you are pushing a box. Then, after some time, pagod ka na. So, paliit ng paliit yung force mo. So, if you'll try to grab the force, sa unang push mo, okay, you're going upward, palakas ng palakas, then napagod ka. So, bumaba yung force mo. So, if it is a variable force, then we'll just have to get the summation of all this. Actually, this can just be solved ito by this figure. You will just add the given the area, or we can just use calculus in solving for a variable force. So maybe I can show you an example of solving for a variable force on a separate discussion. So I'll be giving you an example of solving problem for work with a variable force. But with constant force, we have already discussed this and solved examples in this discussion and on the part 1 of our discussion. So this is our discussion of work, energy, and power. So hopefully it is much more clearer to you now. So just continue to study the modules that I have given you, and together with this video discussion, hopefully you have grasped it a little better and analyze better the problems next time. So this is work, energy, and power.